Hey guys, this is Arish from FTC Don't Blink, and today we're going to be taking a look at an advanced programming topic known as auto adjust or auto aim or whatever the FTC team calls it, and specifically with adjustability on your shooter. And this is a topic that hasn't been covered much. I know there's been talks on the FTC Discord, so um, our team was thinking of making small tutorials on topics such as these, which can help teams with some basic knowledge of advanced programming or software techniques and control system theory to you know um, become even better and refresh their skills in this area. So today we're going to be covering adjustability in shooting. So that means being able to change your shooting speeds, the angle at which you shoot, depending on a certain input. And this is going to be done using something known as a lookup table. And FTC lib, which is an amazing source for anyone who's interested. The link will be in the description. You guys should definitely check that out because you will need it for this tutorial. So they have a really cool piece of software in their library known as Interplet, which stands for Interpolation Lookup Table. And this might seem very intimidating at first, but very simply put, a lookup table basically contains a set of control points that allow you to use the hardware, software, whatever you're using to, do things with those control points. So for us today, I have set up like a very basic shooter class. So you can see here we have an auto adjust tutorial class. It has a very basic DC motor flywheel. We're waiting for start and just while the op is active. Um, and I also have here MS Paint. And this is like a very rough SketchUp of a field drawing that I did. So you can see here, this is a robot. And for today's tutorial, we're going to assume two things. One, that you have a way to localize your robot on the field. And two, you have some adjustability in your shooter, whether that means the speed of your shooter, the angle, or adjusting the whole like the angle of your whole shooter, or using what a lot of teams are doing, a flap. So if you have some form where you can input something and change the output based on the input, then this tutorial should be very straightforward. So for us today, we're going to be assuming that our input is actually this distance sensor right over here, and this extracts the distance from the back wall. And the output is going to be our change in the shooter speed. So a lot of teams this year are using a flywheel, and you can adjust the speed using the motor speeds on your flywheel itself, right? So knowing that you have these two options and adjustability, knowing that you have these options, we're going to go ahead and get started with the tutorial. So basically what we want to do is we want to say that, okay, if we're at the starting line, we know we shoot at some velocity. But what if instead of our robot being over here, it was somewhere over here? Would it still be able to shoot the same distance, right? And so there are two main components over here. One is adjusting the way you shoot. So again, this we just covered is done by your shooting speeds, your flap, your angle adjuster, whatever. But the second thing is also turning to your target. Now we're going to disregard the turning aspect for this tutorial. There's going to be something separate on that since that's a topic of its own. It's more math involved. But for shooting and adjusting the power based on either something relative or absolute is going to be covered today. So again, we're using a distance sensor. So it says it tracks the distance relative to the back wall. But you can also do this with odometry. So if you know where you are on the XY field, so you know your X and Y position, and you know the high goal's X and Y position, you can get your absolute distance with some right triangle trig. And again, we'll cover that more in the future. But say we know our distance is like some constant x, and x is going to be your input. So based on the distance, we want to change our output, which is our shooter speed. So shooter speed is going to be y. So if you have an xy, you can essentially form an equation, right? So what defines this equation? Well, we know that, let's say at 5.5 feet, we want to shoot at, let's say 4,000 RPM, right? And that's going to be our shooting speed at 5.5 feet from the back wall. But say we move this way, right? Say we move down the field, and now our new distance is going to be 4.5 feet. Well, we know that, with some testing that we did on the field, our shooter then is at 3,800 RPM. And, just talking on a different, on a tangent here, like the further back you go, you want, like, if you go at the same speed, what's going to happen is your ring is just going to go overshoot because it's using the same velocity, so it's going to keep climbing until you reach, the dip point of the ring. And the dip point, so like the ring definitely does not travel in this way, but let's say that we're modeling the path of a ring. If you shoot here, it's going to be something like this, right? And the ring has some weird drop off, so I just did that more extravagantly. But if if you're shooting from this distance here, and you go back some more, you're gonna see that it's going to overshoot at this point, right, where it would normally dip over here. So we're just going to assume that it's at 3,800 over here, but let's say you go back even more. You're at that point where the ring is going to dip. So let's say over there, instead of like making that the ring hits the high goal over here, we want it to go up and then curve down into the high goal. Obviously that gets a bit more inconsistent, but let's say our shooter can do that. So let's say at 3.5 feet, our shooter revs back up to like 3,900 RPM. And then at 2.5, it's at 4,000. And then at 1.5, it's like 4,075, right? I'm just making some random numbers. So over here, you can see we have a set of control points. So the input is going to be your distance, and your output is going to be your shooter speed. So let's just take one of these control points. So one of the control points would be 5.5 comma 4,000, right? So once you make a series of these control points, what you have is a lookup table, right? Because a lookup table is essentially comprised of your x and y, and then your x is your input and your y is your output, and then you just make a table based on that. But it looks different in code, so that's what we're going to be going over today. So in code, FTC_lib has a class known as interplet. So if we go ahead and type interplet, and let's just call this our control points, right? So now we have this variable where, or sorry, this object where we can use the methods that FTC_lib provides in order to essentially do what we essentially do what we said over here. We want to adjust power based on an input, and the power is your output, obviously. So what we're going to do first is create a method. So again, this assumes you have some basic Java knowledge. So we're going to create a void method that says create control points. And this essentially says that we have our our interplet object, and we're going to say we want to add a control point. So we said that at 5.5 feet, our output is going to be 4,000 RPM. And we can just add a bunch of these control points. So at 4.5, 3.5, 2.5, or 1.5, and then this just changes based on what we had. So we had 3,800, 3,900, 4,000 again, and then 4,075, right? So if we plot these points, I again went back to my desktop. Great, okay. So if we plot these points on the graph, it'll look something like this. So, well, this is this is assuming it's like, so at 5.5, it's at 4,000. At 4.5, it's at like 3,800. At 3.5, it's 3,900, so which is over here. Then back to 4,000, then to 4,075. So you can see it forms this weird cubic shape, right? And what the interplet class does is it essentially creates a spline, which is like a curve, that goes through each of the control points you define. And it's guaranteed to go through these control points. So that means it's going to be as accurate as the number of control points you give it. So if I only give 2 control points, let's say 5.5 and 1.5, it's just going to assume it's a linear relationship, right? Because that's how it would act. But the more control points you give it, the more the curve is going to follow what your actual variance is going to be. So first, what we want to do is initialize our control points. And then we can just call create control points. And this essentially creates your object with a bunch of these control points that you've defined. And let's say, so we said our input is going to be the distance from a distance sensor. So let's say we have a ref 2 meter distance sensor, and we can call the sensor a shooting sensor. And we can just define it over here quickly. So shooting sensor equals however map.get distance sensor, if I recall correctly. Yep, class, and then let's just call this SS, right? Just for the sake of time. And what did I do here? Okay. So we have our shooting sensor now, and with the way the distance sensors work is we can actually call the distance. So if we say get distance, and then we can say millimeters. We can say, do they have feet? I don't think they have feet. But they have inches, right? And we know that there are 12 inches in a foot. So all we're going to do is divide this by 12 to convert it into feet. And 12.0. Oh, we have to convert this outside. But let's say that we want to make a variable. So we can call this double feet from back wall. And this is going to be whatever the distance sensor reading is divided by 12.0. And remember, we don't want to do 12. We don't want to do some integer division. So we'll just do 12.0. And essentially, now that we have this as our input, so this is going to be like a constant input. We always want to read this, and only when we use our shooter, it's going to give it at that output, right? So let's say this, as for an example tutorial, we're using our shooter inside this while op mode loop. And so what we're going to do here is say we want to set, so our flywheel is our motor, and we want to set power. And well, since it's velocity, we can use, well, I have it set up as a regular motor, right? So since these are velocities, you can essentially use the set velocity method. Actually, we can do that right now. So if I change this to a DC motor X, and I do this here as well, you can see now we get access to a bunch of more methods that allow us to better control the shooter. So say we want to set velocity, and I'm just assuming it's a 1-to-1 bare motor. So this is going to be whatever your velocity is times 28/60, which is like the specifications of the motor, right? So now we're not going to give this a random number, right? We're not going to say we always want it at 4,000. It is going to change based on what this interpolation table tells us. So over here, we're going to say we want to say control points dot get, and you can see if I go back, oh, it was right there. But you can see it asks for double input, and your double input over here is actually going to be the feet from your back wall. So this is going to give us the velocity based on this distance sensor reading. And then we're going to multiply this by 28.0 or 60.0 just to convert it into velocity. Again, this should change depending on your gear ratios or whatever. And finally, oh, actually, yeah, we're done. But just for the sake of making this tutorial a bit more easier for you to tune, I'm going to do one more thing. So what you can do is, if you have FTC dashboard installed, what you can do is you can say add config. And if you're tuning something, what you want to do is make a public static double variable. And let's say this is called velocity. And you can just set it to whatever value you want to start off with. And what add config allows you to do is edit your FTC dashboard values, live using that software. So let's say if we just wanted to test out like the different velocities at a given distance. Can I comment this? Yep. What we can say is we can say flywheel.set velocity velocity times, again, whatever that thing was. And this allows you to change the velocity live. So if you go to the FTC dashboard and if you click your class's dropdown, so auto adjust tutorial would be your dropdown, you can essentially adjust these values live, and that would allow you to tune the shooter based on the distance. So what I like to do is bring out like a small whiteboard, or you can just even put it right into here. And for each distance, you basically read what the distance sensor is, and then you keep like changing the input in FTC dashboard until the velocity is what you want. And then that's one control point. And you do that 5 or 6 times until you feel like you're gonna get it more accurate. And then you create this control table, or sorry, lookup table, and you simply do what I said over here. And yep, that's it for this tutorial. It shouldn't be too bad. Again, if you're using Odometry or something, you can get your own readings, right? So if you're not using feed from backwall, if you're using something else, just change the input in this get method. So anyway, I hope this was useful, and more tutorials to come soon.